review on this one. If we want to use matrix method to solve simultaneous linear equation, we must get the equation into the form ax plus by equals to k. Okay, we must use that form. Exactly ax plus by equals to k. So, for this equation, we will have minus 4x plus y equals to 3, minus 5x plus 2y equals to minus 6. Well, if you also go another way around, 5x minus 2y equals to 6, that's fine as well. Okay, so there will be more than one way you can write this linear equation in the x plus by equals to k form. But just choose a way you feel comfortable with. For example, I will just swap the x, y order and move the 6 to the other side. Okay, that's what we'll have first. And can you see the coefficient? The coefficient for x and y. We will write that in the exact same order. So the order we have is minus 4, 1, minus 5, and 2. Exactly in that box order. Okay? So just drag them down and put into the box. Our times with xy. Our times with xy is a matrix times another matrix. So if you do horizontal and vertical times those two, you will get the top two lines. Okay, so minus 4x plus y, minus 5x plus 2y. That's exactly the same as the above line if you expand the matrix. So that equals to what? That equals to 3 and minus 6, which is the k value. You again list that in the exactly same order. Don't change the order. That's exactly the same. Just a little bit extension. If you have 3 equations here, well, 3 simultaneous linear equation and x, y, z value. So what you put is ax plus by plus cz equals to k form. Okay, 3 variables, 3 equation. So again, in the exactly same order. Okay, 2, 1, 2, 3, 2, minus 1, minus 2, 3, and 4. X, y, z. And then the answer 1, 4, 10. Sometimes it may ask you how to set up the simultaneous equation for these 3 simultaneous equations. So that's how you set up the matrix. Okay, back to this one. How we can solve for it. Let's say we have A times X equals to B. Matrix A times matrix X equals to matrix B. So what we can do is not divide by the matrix A. We can't divide by matrix A. We can only times the inverse of matrix A. Also, as I said yesterday, it is very important to make it in the right order. Okay, in the right order. So what is the right order? A inverse must be times in the front. Okay, A inverse must be times with the in front, because I want to make it get close to the A. Okay, get together. If you put at the back, it will be AX A inverse. It's not working that way. So it must be in the front. So if I time A inverse in the front, the left hand side just left with X. And the right hand side will be minus 4, 1, minus 5, 2 inverse times with the other matrix B. So A inverse must be in the front of matrix B. So AD minus BC minus 4 times 2 minus 1 times minus 5. That's a minus 8 plus 5 is minus a third. And then swap minus 4 and 2 and minus the other 2 values. We'll have that. And then times with 3 and negative 6. I will ignore negative a third first. I will just times the other 2 matrices together. You have 2 times 3 minus 1 times minus 6. That will give you a 12. 5 times 3, 15. 15 plus 24. That gives you a 39. Now you will times the negative a third into the matrix. We have minus 4 and minus 13. Minus 4 and minus 13. Therefore, you can see x is minus 4 and y is minus 13. That's the question we have on the first or second page. Okay, it's exactly the same question. I just use a matrix method to solve for it. Okay. What I want to say here is, if I can find the inverse of A, nothing wrong, like everything's good. I just find the inverse and I times it, I will get the answer. Okay, I will definitely get the answer. The only problem might occur is when I trying to find the inverse and the denominator, which is the determinant of the inverse matrix A. So when I have denominator equals to 0, which means there's something wrong. I can't keep calculating things. Although I can still times this matrix and that matrix, but then we have a 1 over 0. That's something might go wrong when you use matrix method to solve for these simultaneous equations. So we will use that idea to solve the next topic, which is called the geometry of simultaneous linear equations with two variables. Okay. This page is I get from year 11 notes. That's when you think about two linear equations, how many situations you have when you're trying to find the intersection between them. Okay, that's from year 11 notes. That's how when we think about geometrically. Okay, we're trying to think the geometry. Okay, if they're parallel, there's no solutions. If they intersect, have different gradient, there will be one intersections. If they are the same linear, they will have infinite many solutions all on this linear. Okay, I hope we know that. So that's from year 11. Okay, now we'll think from another way. Okay, we'll try to think things in another way, not using the geometric method, because it's quite painful and tedious to do all these calculations. You need to rearrange, you need to see the gradient, you need to see the y-intercept. Well, if you don't know this method, if you have interest in this method, this is a full solution here. Okay, for one question, asking when there's no solution, when there's one solution, and when there's infinite many solutions. That's just an example for you if you're interested in this method. I'm not going to go through that today. But instead, I will show you another method. By using the matrix method. So now what we have is two linear equations. They are already in the form of ax plus by equals to k. I can set up the simultaneous equation for that. So it's k minus 1, 2, 1, k minus 1. X and y equals to 1 and minus k. Okay, if I can write that vertically, you can see that more clear. You should be very familiar with this type of question already from last year, but like we just solve it by using another method because we have learned the matrix. Okay, now I want to solve for xy. Okay, I want to solve for xy. So xy will equals to the inverse of that times that. So I want to find the inverse of that. It will be 1 over AD minus BC. Well, swap those two, they are still the same thing, minus the other two. Times with whatever the answer is. We just suppose k is a value. And then we can just do that. Any questions to that? Up here. Okay. If no, there will be one place it might go wrong. Where do you think it is? Well, I can always swap those two numbers, nothing wrong. I can always negative the other two numbers, nothing wrong. I can always times those two matrices together. Okay, all good. Row, column, times, no problem. The only place there might occur, like problem might occur, is this denominator here. Because I don't know what's the k value. I may just get something, I can make this equal to 0. It might occur something, just get the denominator equals to 0. So that's something, it might go wrong. So I can see k minus 1 squared minus 2 equals to 0. That's when the problem might occur. Okay? So k minus 1 squared equals to 2. K minus 1 will be plus minus root 2. K will be 1 plus minus root 2. Why I solve this equals to 0? Because 0 will be the only problem for this simultaneous equation. Otherwise, I can definitely solve, I can definitely solve out one x and one y value, like a unique solution. Because when you times two matrix, that definitely give you like a row 2, column 1 solution. And then you times another number, that's definitely one solution only. But for that point is the problem point. Okay, I thought that the problem might occur. So, okay, I can answer the question already. So for unique solution, I only need k belongs to R, except 1 minus root 2 and 1 plus root 2. I can already answer the question. Because like, if it's not 0, everything's good. I can definitely solve out whatever I require, I like. Okay? So, nothing wrong. I can answer that is k belongs to R, not belongs to those, not have those 2 points. Because those 2 points is the problem point. Okay, then we have two more question is like infinite many and no solution. Okay, those 2 answers must come from here. Okay, because all the other values are good. The only possibility is coming from this point. So what I will do is I can't tell which one is the infinite many, which one is the no solution. Okay, it's all combined together. I can't tell. So what I will do is sub back to check. Okay, sub back to check. So where I will sub it? I will sub it into the very beginning matrix. So first of all, I will sub k equals to 1 minus root 2. That will give me minus root 2. 2, 1, minus root 2, xy, 1, that's minus 1 plus root 2. Okay, my question here is, are they in proportions? Like, are they in like a particular factor? Like the first one times some factor give you whether the top line times the factor will give you the second line or not. Okay, so we can test. Negative root 2 times, well, let's go for this. 1 times negative root 2 will give you negative root 2, right? Negative root 2 times negative root 2 will give you 2, right? Okay, they are in proportions already, like times negative root 2 times negative root 2. Now what I need to test is whether this times negative root 2 will give you that or not. Will that give you this? That times negative root 2, is that 1? Think about that. Can this number times negative root 2 give you 1? Yes or no? This number times by negative root 2, what is it? If you can't say, just work it out. Is that 1? No. No, okay? That's a no. So if that's a no, which means they are not the same linear. They are not the same linear. Like if you have like all in the same ratio, which means they are the same linear. Like for example, x plus y equals to 1. 2x plus 2y equals to 2. They are the same thing, right? They are the same thing. You just times 2 on both sides of the equation. Minus x minus y equals to minus 1. X plus y equals to 1. They are the same equation. It's just a times a particular number on both sides of the equation. But this means they are not the same equation. Because even though the xy coefficient is in proportion, but the c value is not in proportion, which means they are not the same line. If they are not the same line, there will be no solutions. Okay, they are parallel. They are parallel. Because that's not going to be the unique solution. It can either to be no solution or infinite many solution. Obviously, they are not the same line. They are not the infinite many solution case. So the no solution case will be k equals to 1 minus root 2. But not finished. I will check the other one, because not saying this is the infinite many, then the other one must be no solution, or this is no solution, the other one must be infinite many. It's not that case. Okay, so I need to test again. So sub k equals to 1 plus root 2. What I have is root 2, 1, 2, root 2. xy 1 minus 1 minus root 2. Okay, we can see that the bottom line times, like the 1 times root 2 give you root 2 times root 2 give you 2. But minus 1 minus root 2 times root 2 are not going to give you 1. Again, it's the same problem. Okay, the first two number, okay, all good. Times root 2 times root 2. But the last one is not times by root 2. Okay, the last one you can't times root 2 give yourself 1. Which is still the no solution case. So 1 plus minus root 2 is the no solution case. We have subbed the two problem value into the original equation, and we have figured out for both values they are not the same line. You're not going to give the same line. Okay, you're not going to give the same line. So therefore, both of these k values are not going to give you infinite many solutions. It can only give you no solutions. So for the infinite many solution case, you will answer there's no such k value. There's no such k value to give you infinite many solution for these simultaneous equations. Okay, you need to test both equations to sub that in for both equations. Even though you need to sub it twice, it's still quicker compared to the method I showed you in the previous page. The previous page is more for understanding. You can clearly think about, okay, there are parallel lines, they are not the same line. There are parallel lines, they are the same line, and there are lines not parallel to each other. It's good for understanding for the previous page method, but for this method, it's quick. Okay, you can directly see what is it. It's very straightforward. You need to only solve for one equation. The previous one needs to solve two equations. So this method is quicker. If it doesn't make much sense, I will show you another one. Okay, example B. So for this one, I can set up the equation in this way. Okay, that's how we can set up the matrix equation. That's the first way. First step, what you should do. Be careful with the order. Okay, be careful with the order. If you can't really see it, write them like in two lines. Okay, top and bottom in two lines, and you can see where's all the coefficient. Again, if I want to solve for xy, what all I need to do is do this. Okay, times the inverse of the front matrix. I'm not going to keep writing the inverse for it, because let's say that's the matrix A. So the determinant of A equals to k times k minus 2 minus 3 times 8. That's k squared minus 2k minus 24. Why look at the determinant? If the determinant is not 0, I can have the inverse, and I can directly solve a unique solution. But the only problem is if determinant is 0, what will happen? Okay, so that is k minus 6 and k plus 4. Why I factorize that? Because I want to solve for 0. So k minus 6 and k plus 4 equals to 0. So k equals to minus 4 or k equals to 6. I can answer the unique one. K can be anything else but not -4, not 6. That's the only 2 points you have problem. Okay, have problem with. All the other values for k, that's good. I can find the inverse, I can find a unique solution. If I can find the inverse, I can definitely find a unique solution. Because when I have the inverse, 2 matrix times together will give me a unique value. And at times the coefficient in front, I still have the unique value. So only -4 and 6 is not working well. So unique solution will be R except -4 and 6. Now I will have infinite many and no solutions. So I will sub k equals to -4 first. I need to test. So I have -4, 8, 3, -6, xy, -8, and 1. Can you see from here to here, I need to times by -8. But from here to here, I need to times -4 on 3. Right? I just need to test this last value and the front value. They are not the same. They are not the same. Okay, it's not the same line. They are not the same line. So therefore, for no solution case, k will be -4. They are not the same line. Also, they are not going to give you a unique solution. What's going to happen? No, that's the no solution case. If you sub k equals to 6, what's going to happen? 6, 8, 3, 4, xy, 2, and 1. From bottom to top times 2, bottom to top times 2, bottom to top times by 2. They all times by the same number, which means they are exactly the same line. If they are the same line, you will have infinite many solutions. So k equals to 6 will give you infinite many solutions. Okay, so 2 different examples shows you that sometimes you just don't have infinite many solutions. Okay, just can't have it. There's no such k value will always give the simultaneous equation an infinite many solution case. But for some k value, like you need to really put the k value in and test for it, whether they are the same line or not. If not, then you need to say there's no solution case. If they are in a particular proportion, then that's the infinite many solution case. Any questions? I will recommend this method. Okay, last year I was recommending the other method, like it's better for understanding. I feel students understand that method better, but it's really slow and really needs a long time to solve for it. So this year I will recommend this one. To use the matrix method, I can directly get the answer. but like you need a little bit understanding. This is not from the graph. The understanding is coming from, do I have inverse for a matrix? If I don't have the inverse for a matrix, in either to be no solution case or infinite many solution case. So I'll test the two values, or maybe one sometimes. I'll test that value to see whether it's a no solution or infinite many solution case. Okay, if you don't have any questions, you have 7 minutes to revise on what we have learned. Also correct any of your problem you have on the paper.